Now we will look into an object which has continuous mass distribution. For example, the pencil, right? So pencil is a case of your continuous mass distribution. Okay. So if we have to figure out the center of mass for this, we need to use what? See, the idea will not change. It's the sum of the particles position and the mass divided by the total mass. That idea will not change. So instead of summation, it will change to integration. Because it's continuous mass distribution, we'll use the idea of integration. That's it. So you can see that it's not a big difference. Again, the fundamentals will remain the same. So in case for body with continuous mass distribution, the particles then become differential mass elements. It's just a fancy way of telling very small. That's it. A fancy way to tell very, very small. Small mass actually. Okay, guys. Then, so we have, so this infers from here, we can tell that the idea changes to from sum becomes summation. Sorry, summation becomes integral. That's it. So XCOM will be 1 by m integration of x dm. And similarly, you have everything else. YCOM and ZCOM, I'm not going to write them. So that would be the basic idea. Okay, so other three, you guys finish it up. Other two, sorry. There's one more formula, one more version of this formula that is to do with your density and everything. So let me take the case of. So majorly, guys, we'll deal with only this. Objects with uniform density. I hope you guys understand this. Basically, if you take up any part of the object, the mass will remain the same. Okay, if I take up any part, say, of the same dimensions, of course, the mass will remain the same. So I hope you guys understand this statement, uniform density. By now, you should be able to understand this. You're learnt in previous grades, okay? So we will be looking at uniform dense object. So basically, mass per unit volume will remain the same. So generally, we represent it, rho represents dm by db or m by b. Right, mass per unit volume is represented by rho, and it's constant. This particular value is constant throughout. That's what we're going with. Now, can you see that we have dm everywhere? So we have dm everywhere, right? So what if we substitute dm as m by v? Remember, m and v are constant. So if we substitute over here, your XCOM will become what? M and M will get cancelled, and we have 1 by V integration of X dV. Okay, so the formula will change. Again, guys, everything is possible. As in, sometimes they might not give you guys, or maybe there are cases wherein they will not give you uniform density, for example. Then what to do? You go back to the original idea. If they give you uniform density, like over here, like we are discussing over here, then you can use this directly. The point is, this is going to make your life a lot simpler. Okay. So case by case, you should be able to handle. So there's no fixed rule. I don't want to tell that, okay, you have to use only this formula. So that's why I'm not fixated on the new formulas per se, but I'm fixated on the idea, because ideas are the one which will be useful end of it. Now the questions are changing. The exams that you are facing or you're going to face, the ideas will not stick. The ideas will not be that you have one formula and you just apply it. No, it won't be that. Things are changing. It will be more of application oriented. If you don't have a good hold on the concept, you will not be able to answer. So again, please understand, this is a particular case. And for that case, for those cases, we can use this formula. But the original idea will be applicable for everything. Yeah, now you have to copy this.